I want to make sure that, well, make sure might be a strong word, but we've talked about this topic a lot, and we have concrete proposals now. That's good. PSP is marked as deprecated. That's good. But I'd like to help us to make some real progress and kind of come to some conclusions. And I'd like to make the assertion that we don't all agree on the problem that we're trying to solve right now. And I don't think that we can agree on a solution if we don't agree on the same problem that we're trying to solve. So that's where I would like to start.
I'm a +1 that.
Talking about goals and requirements and make sure we have a common understanding of that. And then we can move on to talking about solutions. So we have some goals written down on the proposals. So maybe that would be a good place to start.
There are two proposals. Which proposal do you want to talk about?
Well, I would like to talk about goals independent of the proposals. I guess these both list out two different sets of goals. So that might be a good starting point to the conversation about goals, but I don't think that we should limit to that or tie it to those specific proposals.
Okay. I'll say one that I didn't notice on these is coexistence with existing and potentially future modes of handling how to prevent the creation of pods and containers that can sort of escape on the host. There are existing solutions. And one of the problems that I observed with PSP is that it was really difficult to get it to play nice with other existing options.
To what end would you want it to play nice with other existing options?
Well, some possibilities include, if we ever want to turn this on by default, I would like to have a growth path to something different. Or if somebody's using something different and they want to try to use this, I would want them both to be able to coexist.
Yeah, my understanding of both of the designs is that they could coexist nicely with third-party things, like with K-Rail or Caverno or Gatekeeper, because of course the design of admission controllers is that anybody can vote a pod out, and so you need to have consensus from all of your admission controllers. So from a just having it defaulted to on standpoint, either one of these can be defanged relatively easily. The container boundary policy proposal, if you simply don't have any bindings, then it doesn't enforce anything, whether it's turned on or not.
So there's a state where you want it on for some namespaces and off for others, right? There's also a state that we have today with PSP where it's effectively on for some users and not on for others. I think both of those dimensions are important.
Are you
let me briefly pause you. Is anyone willing to volunteer to take notes?
I'm starting. I'm happy to write when I'm not talking, but I don't want to commit to not talking for the whole hour. So if 2 or 3 people could, that would be helpful.
Jordan, are you taking notes like in the sig-auth agenda or somewhere?
Yeah, Tim had, I assume it was Tim started a breakout session item.
Okay.
It's easier to just keep notes in the same place.
Yeah, and
is that linked from the sig-auth agenda, or? I'm not
yeah,
sure.
and if you, I'll help too if you all put the link in, because I'm not sure where the doc is. So. Well, it's quiet. Hi, Mo.
Long time.
I know, huh?
So
I have
so
another kid now. I have two instead of one.
Oh, my Lord. I imagine they keep you busy.
And sleep
Oh.
deprived.
So to the you want enforcement from one policy engine on some namespaces and from a different policy engine on on other namespaces point is binding a policy that allows everything into the namespaces in engine B so that it's only affected by the policies of engine A. Like, does that suffice to your desire, or do you want it to be even more disinterested?
So the namespace boundary is one of two dimensions, right? The other dimension that exists today and that other people enforce on is the user who is actually making the request. So the namespace dimension is half. I would actually suggest that something like a namespace label would be more consistent with how webhook admission is done today. But the dimension of what user is requesting a pod also seems to be one that we would need to take into account.
I actually consider the enforcement of policy based on the requesting user to be extremely problematic.
Yeah, that's a bug.
So I'm not.
Yeah, plus one. I think it's a miss feature in PSP.
So one, that isn't universally held. And two, this isn't asking for enforcement by user. This is asking for a switch on whether the admission plugin operates at all based on user.
That is enforcement. I mean, if it doesn't enforce, then it is effectively privileged. So I'm not sure what you mean by it's not asking to enforce by user.
Okay. I could see it that way, but yes, I think that is actually something valuable, right? It allows someone to create pods in a namespace that are quoted to a particular namespace that cannot be exec to, that cannot be modified, that can come from a trusted source, so that you can charge a particular namespace, but you can create a controlled pod that a user could not.
Slicing by user, if we had better, let me rephrase that. If we had delegation mechanisms where a controller could carry through the identity of the user that originated the object through the various levels of intermediate objects, or we had delegation mechanisms that would say, I can let you have permission to do this as me or on my behalf, scoped down. If we had those things, then user enforcement might be more reasonable. But every person that I see who encounters the feature in pod security policy, which allows either because of the user or bypasses because of the user in your terms, is confused by it and thinks they've discovered a security hole.
So this is why I wanted to start with talking about goals and requirements, though, because
so I'll go with. Sorry.
I don't necessarily think we should say that some sort of delegation mechanism or propagation of properties down to requests is something we should rule out at this stage. Like if that's actually what we need to do to really solve the problem we're trying to solve here, then I think we should consider it.
It's by far the most common complaint that folks have had about either one of these proposals is there's no way to mix privilege levels within a namespace. And my response to that has always been yes, because in Kubernetes, there's no practical, strong way to mix privilege levels within a namespace. So, the way that PSP does it by the user is an exception, but encourages you to create raw pod objects, which everything else in Kubernetes discourages you from doing.
It depends on what you're building or developing. So counterexample would be something like an OpenShift build pod, where there is a controller similar to a job controller, where a user creates the equivalent of a job or a cron job or something that is going to result in a pod. And the shape of those pods is tightly controlled. But the power that the pod wants to have is normally elevated compared to what a regular user does. So you want a regular user to be controlled and say the number of pods they can create. Same reason you would put quota in a namespace that had a job, for instance, and you would quota pods. But you have this controller, which is creating very carefully constructed pods directly, like any normal workload controller would do. And it has a need to create pods that a service account does not have sufficient privileges to create.
And so right now, you would like the idea of solving that problem using the user binding of PSP and having that controller be accessing it using certain credentials that are allowed by
To
that
be
PSP
very
binding.
specific, what David is saying is he wants the behavior that SCC had, which PSP also has, which is that there's two user actors that are considered on does the policy match or does the policy enforce.
And rather than try to go and say, I want to have all the power of these APIs based on the user, I'm not looking for that. I'm looking for a way to coexist and say, you know what, this user isn't bound at all. If he requests it maybe on an annotation on the pod. So he has an option. So not asking for enforcement or dual consideration or trying to make this API honor multiple actors, but a way to have multiple possible engines run with maybe two different sets of capabilities.
So I have a question about this notion of user enforcement, and there's a special user that is allowed to perform this action. And that's validating if state is okay after the fact, right? Because at the boundary, you have this requesting user info. But if you're looking at the state of the cluster and you're just looking at the pods that exist, is there some way to verify that every running pod was created by a user who had the appropriate privileges?
Pods are immutable, largely, which is the only reason this is even close to possible today. Right now, mutation of existing pods is very rare because very few fields can be changed, pretty much just image. And that's sort of considered an anti-pattern. And so if something updates the pod, then this policy could check again that the current user trying to update the pod was allowed to do stuff. That's what PSP does. That's what OpenShift's similar policy does. Nothing in Cube periodically sweeps existing objects and makes sure that the user that created them is still authorized to have created them if they created them at the current point in time. Nothing does that. So this policy would be no different.
I think Max's point is, at least my interpretation, correct me if I'm wrong, Max, it's useful to be able to say, like, for example, for PCI compliance, right? We have some policies in place. We need to be able to go to prove to an auditor that these policies are being enforced as we expect them to be enforced across the cluster. And if I don't have a clear way of saying that, yes, this privileged pod was created by a privileged user, and easily be able to validate that in the current cluster, I think it's harder to do that. Of course, you can use audit logs and other methods, but
even without that, in a case like this, we wouldn't be asking any auditing tool to do that. What will come down is there would be a list of, hey, these pods all look suspicious, and there would be the manual check of, okay, is the image one we expect from this build? Does it match exactly what the shape of this build pod is? Yes, it does. Okay, you're fine. But we wouldn't expect Cube to have a policy that allows us to select like this particular image, these particular arguments, with this combination of persistent volumes, yes, this is safe. That's excessive to try to enforce in any reasonable way.
Just to time box the goals discussion and maybe get to evaluation, I think David's point is useful. I'm not sure I agree with the user dimension, but that's a useful perspective. I would like to very quickly throw a few other goals out. I think that whatever we come up with should be validating only. I think changing pods in order to make them comply with a policy is very difficult to reason about and has not generally worked well. It often breaks more things than it fixes and breaks them in more subtle and hard to understand ways. So I think a goal should be a validating only policy.
I'd like to go all the way to the beginning and say that a goal is to have some kind of policy engine in tree so that you can run pure Kubernetes and configure it in such a way that create pod is not automatically root on every node in the cluster.
What she said.
Like, I think that most of us are here because we share that goal, but I think it's important to actually say that goal, because if we just fight with each other, then we will eventually reach a state in 1.26 where we have all lost that goal because PSP will go away.
I think that's a really good point.
Um,
And I think it's really important to have things in tree, partly because if it is the case with one specific commercial distribution that it is secure, that does not mean that it is secure on every other distribution for everybody else. And I think it's really important to keep that in mind.
I definitely agree on the goal of running a pod is not equal to root on cluster. There is some fuzziness there, though. So there's certain fields where we can say kind of unilaterally, like, this is root on cluster if you have this, or root on the node at least. There are some other ones where it's a significant weakening of the attack boundary, but we would probably, weakening of the isolation boundary, increase of the attack surface. But we would still consider it a vulnerability if you could escape a container with just that permission. And then there's some that are even a step further than that, where it's like, this field is only further scoping down the attack surface and limiting permissions. Is it worth discussing kind of where we want to draw the line around that?
I think later.
Eventually, but probably not right now. I think we're still talking through high level stuff.
I mean, maybe at the simplest level, we can just assume that, I don't know, you're running a very normal cube distribution. So basically, privileged pod is root on cluster. You can just say that it is. And so
I would be careful about the distinction between cluster and node, personally.
Oh, sure, fine. Okay. You're root on the node, and then you can do bad things as the node.
Is Windows in scope?
Does Windows work on cube at all in a useful manner?
I think Windows should not be in scope right now because the privilege model for Windows is completely different than the privilege model for Linux, and the pod structure is also so very focused around what the privilege model for Linux is, and the privilege model for Windows is still so actively evolving. I think that eventually Windows should be in scope, but I don't think Windows should be in scope right now.
Yeah, it'd be good to design with maybe a place to have Windows live in this new system, but not necessarily so we're not running into the same issues in the past where we have to fit Windows concepts into these pod security policies, but not necessarily limit them to Windows, or not enforce them for Windows today.
Yeah, I agree. I think we need to think about, even if Windows isn't in scope for the initial enforcement, we need to make sure that there's a path to getting there.
To expanding it, yeah.
One of the things that I'm acutely aware of, having had to deal with evolution of PSP over the past several years, is that the compatibility of policy enforcement over releases is really hard, especially if down the road we figure out, okay, we've figured out the Windows permission model. We realize that by default, like, yeah, you can escalate to root on node, on a Windows node. We would like whatever policy we come up with here, whether it's the simple one or the baseline one or the PS, like, we would like to make it so that if you had applied a baseline policy to all your namespaces, they now keep you from getting root on Windows nodes. That would be a breaking change. And that would put us in a similar place to where PSP is at today, where like the best practice policies of 4 years ago, actually you would want to like tighten the screws down a lot more now. So it's, I mean, if the Windows permission model is not well defined right now, then there's not really a lot we can do to lock it down right now. But at the same time, saying like we would make it better in the future. Like I hear that and I think, we're going to break people and they're going to upgrade and they're going to break and they're coming to us and be mad. So the goal of this being safe to enable by default is a good goal. And I'm wondering how we accomplish that goal over time for new things like that.
I think that's one of the key strengths of the like container boundary policy PSP++ kind of proposal model, where what we ship is some example policies that are like versioned in their names and not the bindings. So then within a particular distribution, they can decide that, they're going to make kubeadm clusters be secure by default by having a default binding of like a baseline policy. And maybe in a future version, there is a breaking change where a particular pod would be admitted by the default policy on a 1.26 cluster, but not a 1.27 cluster. But if you have a 1.26 cluster and you upgrade it to 1.27, you are still using the same policies that you were before, because all the upgrade does is give you additional pre-built policies, but isn't altering the enforcement of what you have there. And so it's a way to soften that breaking change by making it so that it is breaking but opt-inable. Like if you are doing just in-place cluster upgrades, you should be safe. But if you want the new hardening things, you'll need to take changes to get them. And if you're installing new clusters on newer versions, I hope that you're doing validation before turning them loose. And as part of that validation, seeing that the defaults in new version foo+1 clusters are no longer compatible with what you have, and you need to either alter your pods or you need to alter the policies that you're using. But like you're giving the user the choice there, so that we don't have to always come up with a perfect answer that's forward compatible while also hardening things.
David?
So, comparing that against the idea of having red, yellow, green policies, I think I would be very surprised if I were a user and I selected a green policy and then I later upgraded and some new field wasn't being considered by whatever the stock resource I had was. And suddenly a new pod got created and this enforcement on the new field didn't happen. So my green policy didn't actually protect me anymore. And especially since these sorts of things are usually additive, I would actually, as a cluster admin, have to try to keep up with a newly named policy each time, create the bindings, remove the existing bindings somehow simultaneously across my cluster to be safe.
Tim, your proposal made an assertion about the baseline policy. So the bare minimum pod security proposal proposed just to enforce the baseline pod security standard, saying that that would not need to be versioned. Oh, I think Windows is a good example for that, where if in the future the Windows permission model is clarified and we realize that current, like if you create a Windows pod today, it is effectively privileged. I mean, I'm hand waving, so maybe that's not the case, but in the future, we realize that the defaults of today are effectively insecure. Would we not want to improve the baseline policy to exclude that case?
Yeah. I would advocate to change the defaults in that case, and to continue to track the defaults with the policy and say that actually that's a case where our defaults are broken. I know that's proved challenging in the past, but also if our defaults are equal to privileged pod, then I think we can make that happen. Also, to David's point, I don't think you would need to do a version bump to add enforcements on a new field, as long as the default value is still allowed. I think it's only when you want to place further restrictions on a new field or change the restrictions on existing fields that you need a version bump.
So that's exactly the case I was just describing, where we realize the defaults are bad, or there's a new field that says like, actually don't be privileged on Windows or whatever OS. I don't want to pick on Windows. And so an existing policy that wasn't enforcing on that field, like according to compatibility policies, would say like keep allowing things you previously allowed in. I was actually wondering, like in terms of API surface, I really like the simplicity of pod security standards, like saying, like, we've thought about all the fields, we've categorized them this way, we have red, yellow, green policies. Those might change over time. I think having a way to capture, like in 1.15, this is what they were. In 1.16, this is what they were. In 1.17, this is what they were. And then let people either select red, yellow, green, like pinning to a version, say, I want the green for 1.15 because I don't trust you guys to like not break me on upgrades. I want to do my own validation. So I'm going to be 1.15 green. And I'll do my own validation, figure out when I want to move to 1.16 green. Or they can flip and say, I want to be green. And that means green latest, like whatever green is on the version that I'm on. To me, that's a much easier thing to communicate than taking our documentation about all the fields in the pod spec and making that an API and giving control over all of those things to end users. So like and this goes back to goals, if the goal is to be able to give people an out-of-the-box enforcement mechanism that accomplishes roughly the level of granularity that pod security standards has, and does it in a way that is possible for us to maintain and possible for people to reason about the compatibility of, I think we can do that without exposing every switch and knob in pod security standards in an API.
Then it would, if I understand correctly, that would be essentially the same as the like PSP++ type of proposal, except that instead of shipping user modifiable policy definition objects that got versioned and that they could choose to use or not, it would be hard coded in code and they could choose to use it or not.
Yep.
I think the difference between the proposals kind of disappears at that point, right?
I don't think it does. If it's a library, if it's a here are the policies, here's what they mean. It's a library that can be reused, but you are bounded to this set of policies instead of, like, we exposed an API that was powerful enough to express these policies, but also powerful enough to express like
any other policy
infinite,
you might want.
infinite combinations.
So what happens if somebody needs other policies? What are their alternatives? Because I know we already have customers who absolutely need custom policies.
I mean,
think
two
that
options
goes back
there.
to the first goal that was described, where you have a way to coexist. If you say these red, yellow, green policies aren't sufficient, then you put policy using a different mechanism in place and you punch a hole through this one to your custom policy.
And we are not yet defining what those other mechanisms are.
No, those other mechanisms have existed since 1.14. So you can put webhook protections around pod creation and delegate to Gatekeeper or OPA.
Yeah.
Or, I mean,
okay.
And that would accommodate people who wanted to policy on dimensions that we didn't consider, or express conditional policies, or if the image is in this specifically allowed set, then it's okay for it to be a privileged pod, or whatever. Like, come up with as complex of a condition as you want.
Like, I think with Gatekeeper, you could do the thing that David wants, where if the user who requested the pod is on a certain allowed list, then it can be privileged. Like, I'm pretty sure you could do that with Gatekeeper today.
I could do that as long as the coexistence was built in such a way that I would be able to say, I don't want this user to be constrained by the container boundary admission plugin. That's why the dimensions of coexistence matter.
I don't know that, I don't think it's reasonable to say every dimension that someone could want to use to bypass must be considered by this mechanism.
This one in particular is one that we know has existed. It has clear use cases. We both helped develop those use cases. It has...
The look on Jordan's face is just great.
I mean, he helped me build it. It has active users, and it is one that we have recognized for other similar boundaries like priority and fairness, where who you are matters, and so does where you're trying to touch a thing. So this isn't everything. This is looking at the state of the art, looking at what we previously had, looking what exists today. This is one that we know people rely on.
It's also one we know people are extremely confused by and concerned by when it hits them. And we know that not everyone understands or expects it. And
so
a
if
policy
you don't...
mechanism that is not easy to predict what it will do is, I don't consider that a goal.
It much depends on how you try to describe the boundary. It doesn't have to be hard to understand. It could be as simple as when you configure the admission plugin, give me a list of users. Never something that hits by default, nothing based on an ACL, right? There are many ways you could configure such a thing. But
I think if we need that we could also simply turn off the offending admission controller in the API server config. Like, if you have needs that are so specialized,
I think David,
you need
David
something
wants,
that's way beyond this, just turn
David
this off.
wants the
please.
benefit of this for normal users.
Right.
So he wants to be able to use the functionality this provides, but then bypass it for
specific scenarios. And
so it's not just coexistence, it's coexistence and use. which is different than just coexistence.
It's
just coexistence says you can bypass and delegate to something else.
It's coexistence based on the dimensions that we know are used today to make different decisions. It's not asking for those decisions to be made. It's not asking to be able to apply red, yellow, green specifically to them. It is simply looking and saying, if I want these two systems to exist, what dimensions are important? What would stop a user from being able to turn this on? And this is one of them.
Kristen, go ahead.
Yeah, I haven't puzzled it all the way through in my head, but I'm thinking about scenarios where I know, we have a cluster where, customer environment where by default they want to use the restricted SCC, so the most restricted out of the box PSP that OpenShift offers, and they must allow. They have had to create 3 custom SCCs for specific use cases. This is particular to networking functions and features, because in the networking space, the CNI APIs don't give them everything they need yet. And they absolutely want these, to manage the application of these privileges based on, it's a CNF, who's deploying the CNF, what privs does that user have on the cluster, what namespace are they running in. So I think it's very similar to what David is teeing up. It's just a very concrete scenario where I'm trying to, in my head, try and figure out, okay, if we're not doing that all with the equivalent of PSPs, is Open Gatekeeper sufficient alternative? But again, it is, and how does it coexist? Because they want by default the most restricted, and they only want to allow privilege in very specific scenarios in specific namespaces, and sometimes those coexist with less privileged pods in the same namespace. So it's a real world scenario, and I just haven't yet wrapped my brain around how they do that. But when I think about it in terms of goals, they want to minimize privilege as much as possible and only allow very specific escapes for those, and they want to still constrain those as much as possible. They don't just want to say, go ahead.
Oh, sorry, I was wondering, can that potentially be addressed by, so we define red, yellow, green in our super restrictive default thing, and then we also say, by the way, here's the equivalent of this policy in Gatekeeper, here's the equivalent of this policy in XYZ policy flavor of the month.
If those policies, right, so you're saying that those would be, so you're going down the path of turn off, you use one or the other, you don't use the two together. But we're giving you a way to use the red, yellow, green in Gatekeeper?
Yeah, I think so.
And I think that we don't have sufficient controls in Kubernetes, I would say, to effectively have exceptional pods at a sub-namespace level without further configuration of policy. So for instance, if you are giving a user, a user can create these privileged pods. Now you also need to worry about which users can exec into those pods, which users can create ephemeral containers on those pods or update the images on those pods. And these other pieces that come with that. And so you need that additional security enforcement anyway. And so at that point, you're talking about adding on a new kind of third-party system to manage that. And at that point, I would suggest that that third-party system should also just handle the full suite of things. And we definitely need that good documentation of this is the policies and here's the details so you can port it to whatever system you want.
I think there is a choice between saying you just can't use this tool and saying, you know what, we know what dimensions exist, we know what the likely ones are, and if you go through and punch this user through and allow him to do whatever, you're responsible for figuring out whether an exec can be done, whether an attach can be done. whether you're allowed to port forward or modify this pod. It becomes your responsibility. But allowing that dimension to exist seems pretty valuable to me. I mean, obviously I'm biased because I use it, but I'm looking at it saying like, I have the ability, I can go through and I could patch this admission plugin for myself, right? It would be 10 lines, patch it, be done with it. But it doesn't help everyone else who doesn't run a distro and can't just patch cube.
So I'd like to time box this because I think this is a requirement that we could fit into a lot of different proposals. And so I think we can kind of push that out a bit. I think I'm hearing maybe three goals. One is create pod and cluster is not root on node. We want something built in and functional out of the box. And I'm blanking on the third one.
I said validating.
It needs to be able to evolve over time.
Yes, thank you. It needs to be composable, I would say. That's the goal. Or coexist. Maybe the coexistence we don't agree on, but there needs to be a way to at least bypass this, flip it off at some level, even if that's cluster-wide or namespace-wide, to say, I'm going to deal with this with another system. And then I think we get into more, I don't want to get into the nuances of the wording, but I would call these other things more requirements of, so that's the goal, that's the problem we're trying to solve. And then there's requirements on what that solution looks like. It needs to be able to evolve over time.
I would also split that into two pieces. Like, we need to have a clear way to maintain it and improve it when needed. And then consumers need to have a clear way to like have their compatibility guarantees met or opt into our improved versions. So there's our side is the maintainers, producers, and there's the consumer, like confidence and compatibility, but also confidence that, no, I really did want the latest, greatest. Like, please tighten permissions if that's what needed to happen. So.
I'm biased, but I agree with all of those goals and requirements, and those are the goals and requirements in the PSP++ doc. So,
But I think as this conversation has been going, I think a lot of us have the same goals, and I think we're in more agreement than I think it has always been entirely reflected. In terms of how fighty we're all describing this conversation to be, and I think if we know that we are working toward the same North Star of the same set of goals, then after that, it's implementation details. And that I think is a very different conversation and a good one.
Tim, do you feel like all the pain points that you had listed out previously, like the inability to dry run and stuff like that, is sufficiently covered in that list that you just went through?
I don't think so.
Anyway, it might be good to like cross check and make sure that there aren't any like big things like lurking from like previous like gap analyses.
Yeah, the safe to enable in new and upgraded clusters. I don't know if it's a goal or a requirement. You'll have to tell me, Tim. But I think that implies like the ability to test a policy, like, and see if it's going to break existing stuff before you enable it. But we might want to make that explicit.
Yeah, I guess there's a goal that this is easy to enable on an existing cluster. I would call that.
Like as a prerequisite for being able to flip it to on by default?
Yeah. And even if it's on by default, that's not always on. So you still need to be able to go from the off state to the on state relatively easily. I think dry run is one approach to that. We haven't talked about non-goals at all. I don't know how deep we want to go on that, but something that I know a lot of the third-party controllers are working on is integration into CI systems. And so I would say it's worth explicitly stating that we're not building a tool that can run outside of Kubernetes unless we think we should, in which case we can add that. But are we scoping this down to runtime enforcement in a Kubernetes cluster?
I think so, because there's so many different ways that people template their manifests that, like, even just saying, I want to validate against policy in CI, like, can depend very much on, well, what set of values are you cramming into the Helm chart, for example. And so with something that's just inside Kubernetes, there is a kind of nasty but workable option where you have a tiny cluster that doesn't do anything, but have people do applies with dry run against it and feed the results back into CI. So like,
yeah, or you could convince yourself you could build a separate linter that like just checks the YAML against, you know, the policy. But that's like, you know, you could consider that separately or orthogonally to what we're talking about here.
Yeah, I think a lot of the natural implementations could be exported, you know, put in a package where you could wrap a linter around it or a command line tool or a CI tool or something around it and evaluate it against pods and CI or wherever. But I wouldn't make that a requirement for this.
I feel like there's so many corner cases. If you make it a requirement, somebody will always be able to find a corner case that torpedoes your ability to maintain it.
Another problem that was called out before with pod security policy is the sort of unbounded nature of the API, that it's not always clear whether a field or something should be added to the policy. And this kind of gets back towards what I was saying earlier on around the fuzziness of the goal of preventing privilege escalation. So we can punt on that, but at some point I think we need to address that issue of what exactly is in scope for this, you know, short of going to a full arbitrary policy engine enforce anything on any field.
Yeah. I know we had asked people to think about like the philosophy of pod security policy. I can give my 20-second version of it. I thought about like the dimensions like confidentiality, integrity, availability. And I tend to separate out availability and say, those are either just bugs that should be fixed or they're quota issues or they're scheduling policy. And so I would not generally look at a field and say, we should control it in pod security standards or pod security policy because of availability. Like this is a DOS risk. Confidentiality and integrity, I think apply. So like host access or volume access or escalated capabilities or privileges or syscontrols or run as user. Like those are the types of things that I was imagining focusing this on.
When I thought about it, oh, sorry.
What about network level stuff? Host ports?
So being able to consume host ports like seem like a resource on the nodes. Like the two dimensions are host access, so host level. So I could see it from a host perspective, but not a resource consumption perspective. So yes or no, maybe could belong in this, but not only these ones and only this number. Does that make sense?
Yeah. HTTP probes is another one that comes to mind, kind of has some interactions with network policy and network level stuff. I put together a spreadsheet. I'm not sure if folks had a chance to look at that, where I was trying to kind of think about these questions for every field in the pod spec.
David has a hand too.
Sorry, go ahead, David.
Yeah, when I was thinking about it, I came up with, I wanted to have 5 or fewer policies. That was very effective in OpenShift when we shipped 5 and said choose from these. I also like evolution over time, where the intent is maintained, as opposed to precise, keep the same things that should have been enforced but weren't working. So intent-based evolution was very important, and we have generally followed with that. And then being able to handle, I guess as a litmus test for that, like how would you handle runtime class as it comes in? Because that has very clear implications. You know, if you use Kata containers or gvisor, or if you have a Windows container runtime class, that's pretty significant implications for how you build an API. And then coexistence. How do you turn this on in a cluster? And how do you turn it off in a cluster in a controlled way where you can sort of migrate over time instead of a big bang? So that was what I came up with for my list.
I have a small question. I'm from Aqua Security, and I wasn't on the other calls. So in Aqua, we've implemented an admission controller using Rego. And recently, we open sourced the Rego library for the pod security standards. And I'm wondering whether you plan to use Rego for the future PSP Plus, like you said, because that would allow users to do that in the CI/CD and also use the same policies in Kubernetes.
We haven't talked about building a Rego engine or OPA or anything like that into Kubernetes. I think that's probably off the table. That would be a pretty significant increase in complexity.
I would like users to be able to choose carefully between your offering and Gatekeeper's offering and Caverno's offering and K-Rail's offering if you have decided that the inbox one is too simple for your needs.
Kirsten has a hand up, and then I want to briefly summarize and talk about the next step.
Really, just a clarifying question, actually. Tim, when you were talking about host ports, the ability to ensure that there's no access to host port is a big win with the majority of the OpenShift customers. I wasn't quite sure what you were trying to say when you mentioned host ports. Were you saying we shouldn't be concerned about them? I wasn't clear.
It's not clear to me that host ports are preventing, like blocking host ports are preventing a privilege escalation, a confidentiality breach, or an integrity breach.
Yeah.
I see it as, there's interactions with network policy.
Yep.
And so that was kind of my questions around, where we see the overlap with this in network policy.
Okay, so I would just say that the customers, the security conscious customers I talk to, blocking access to the host port is always a topic of conversation and something they generally want.
It sounded like other people were looking at the container host boundary, and so that,
Yep.
that would fall under that.
Correct. Yeah.
I want to be respectful of everyone's time. Thank you, everyone. I found this super helpful. As far as next steps, I would like to write up and summarize what we talked about in terms of goals, requirements, non-goals, and whatnot. And maybe we can carry on some of the discussion on that document. And then I'd like to schedule another one of these sessions 2 weeks out at the same time to dig into the implementation side of things. Yeah, and we are at time. So any concerns about that plan, feel free to say so on Slack or the mailing list. All right, thank you, everyone.